For section 4, we're going to start talking about how to graph these rational functions. So we're going to kind of step away from adding and subtracting, multiplying and dividing, like trying to combine them. We're going to focus on if they gave us a rational function, how would we graph it? What would it look like? So we've talked about other types of graphs in the past, like quadratic graphs. We've talked about linear graphs. We talked about different polynomial graphs last chapter and kind of how they have different movement. Rational graphs or rational functions is going to look kind of like an inverse function a little bit, where there's going to be two sides of it, and they're going to almost like mirror image each other. They're going to look very similar, but we have to talk about some of like the limits and areas that cannot be crossed or cannot exist when you're talking about these rational functions, because when we were adding and subtracting and multiplying and dividing, we had those problems that would say state what values x can't be, because it would cause the function to become undefined. So we have to take those into consideration when we're graphing, that there's probably some values out there that our x can't be equal to, because it would cause you to get a 0 in the denominator, which is a big problem. So we'll talk about how do you find those things and how do you graph them. So remember, this is just basic examples right here of what these rational functions might look like. So like 1 over x, x squared plus 1 over 2x. Those would be examples of these rational functions that we're trying to graph now. So the graph of a rational function is called a hyperbola, and it has two separate, what we call branches. So it has two separate parts to the graph. So I'm just going to draw a really basic example up here for you guys, and you can just kind of sketch this in on your guys' notes. Okay, but we have these things called asymptotes. Okay, this word right here, asymptote. That's a line that your graph is going to approach, but it's never going to cross it. It's never going to touch it. Just like when we did our graphs that were like raised to an exponent, when you guys were working with like your logarithms last chapter, we talked about those graphs and how they always approach like the y-axis, but they never actually crossed it. You're going to have situations like that with these rational functions, and those parts that we can't cross are called the asymptotes. Okay, so for example, for like the parent graph of rational functions, which would just be that 1 over x, your asymptotes are going to be the x-axis and the y-axis. So we usually draw those in using a dotted line. So I'm just going over my x and y-axis here in red. So those are going to be my asymptotes. And so my graph would live kind of in those quadrants, but it wouldn't ever be able to cross the x and y axis here. And like I said, I'm going to have two branches. They're going to look very similar to each other, and they're almost going to be like inverses because they're kind of right across from each other. Like they almost have this line in the middle that's acting like that mirror, which we saw when we were dealing with our inverse graphs a while ago. Okay, so we show our asymptotes using dashed lines, and I'm going to talk about how do you find those? Like how do you know what values it should be at? Because they're not all going to be the x and y axis. You'll have some where it's at x equals 2 or x equals negative 2. Okay, so we can transform rational functions using this equation here. Way back at the beginning of the school year, when we talked about transforming graphs. This is when we were taking graphs and we were moving it like left, right, up, down. We were changing the way it looked, and all of that had to deal with where you're adding numbers in on your graph. If it was included in the parentheses, if it was outside of the parentheses, like whether that meant it went up and down. And the same thing happens here with these rational functions. If we have numbers being taken from the variable in the denominator, so like this has x minus h, h is known as that vertical asymptote, so whatever that would equal. So when x equals h, that's going to be your vertical asymptote. So that's going to be the one that goes up and down on your graph. K, so that would be any number that's added or subtracted to the outside of your rational function. That's going to be your horizontal asymptote. So those are going to be the ones that go left to right. Okay, and then domain and range, that just tells us that your x cannot equal that h value because it would cause it to become undefined. So you're asking yourself, what numbers, if I put in to x, am I going to get a 0? Because then that's going to cause you to have an undefined function. And same thing with your y. Y can't equal the k value. You can't ever cross that. Sorry, I'm going the wrong way. You can't ever cross that line. So let's take a look at an example here. Underneath this one, you guys should see this. It says f of x equals 1 over x plus 3 minus 2. Okay, so I'm going to start with your vertical asymptote. I'm going to abbreviate with VA for vertical asymptote. Okay, you guys can abbreviate as well. You don't have to write that all out. But remember, your vertical asymptote is where your x value equals h. So it's basically what value would cause this function to become undefined. So if you guys look at the denominator of your fraction there, it says x plus 3. If I set that equal to 0, and I tried to solve for x, so you guys did this if you were simplifying this by adding or subtracting these fractions together. If I set this equal to 0 and I solved for x, that would give me the values that x can't be, because it would cause this to become undefined. So you guys would have subtracted 3 from 0, and you would have said x equals negative 3. So that's my vertical asymptote, x equals negative 3. So we'll have to draw a line, a vertical line at x equals negative 3. That's going to be one of my asymptotes. Now we also have the horizontal asymptote, okay? And again, I'm going to abbreviate that as HA. That's when your y equals your k. And that comes from the number that's added or subtracted to the fraction. So it's outside of the fraction. So in this case, do you guys see how it says minus 2 after the fraction? That's your vertical asymptote then. So that means that y has to equal that number. Y is going to equal negative 2. So for the vertical asymptote, always take the denominator and set it equal to 0 and say what value x cannot be equal to there. So that would be, in this case, negative 3. And for the horizontal asymptote, it's always the number that's after the fraction. So whatever got added or subtracted. Okay, so then to kind of get us some points for this graph, because you don't need to plug in a huge amount of points, you just need a couple so that when we go to graph it, we have an idea of what it's going to look like. You're going to want to make an XY chart here. Remember, y is the same thing as f of x. So if you put x and then f of x, or x and y and f of x represent the same thing. So what I do then is I pick a couple of points on either side of my vertical asymptote, because at x equals negative 3, that's an undefined function. So nothing's going to happen at that point. There's going to be no graph there. So I want to pick points on either side of negative 3. So for example, like negative 5 and negative 4. Those would be on the left side of negative 3. And if I'm then going across negative 3 towards 0, I would be looking at like negative 2 and negative 1. Now you take these x values and you plug it into your function. So you plug it into that 1 over x plus 3 and then subtract 2. So if you have a calculator, we're going to do this, and you're probably, for some, you may not get whole numbers. You're probably going to get some decimals when you do some of these problems, and that's okay. So for this first one, if we think about this for a second, if I put in a negative 5, what's negative 5 plus 3? Negative 2. So I have 1 over negative 2. So 1 divided by negative 2 is negative 1/2. And then if I subtract 2, because I have a minus 2 on the outside, I should get negative 2.5. Okay, so now let's do negative 4. What's negative 4 plus 3? What's negative 4 plus 3? Negative 1. So what's 1 divided by negative 1? Negative 1. And then we subtract 2. So we're going to have negative 3. Okay, take a minute and try to fill out the other side of that chart there. So when I put in -2, I got -1. And -1, I got -1.5. Okay? Now, if it helps you, I have seen some students will put -3 in the middle of their chart and they'll just kind of draw a line to kind of tell them like that's where it becomes undefined, and that's why I'm picking -5 and -4, -2, -1, because they're on either side of that. You do not need to include that in there, but if it helps you understand like where did I get those numbers from, I'm not just picking them out because I decided they looked good. Okay, I picked them out because they're related to that vertical asymptote, so it's going to give me a good picture of the graph without getting huge numbers that I can't actually graph. Okay, so now what I'm going to do is take all of this information, my asymptotes and this chart here, and we're going to graph it. I would start by drawing your asymptotes, okay, because those are going to kind of be those boundaries that your graph cannot go across. It can't hit those lines. So x equals -3. You go to the x-axis, which is your horizontal axis here. You're going to go to the left 3 because that's -3. And you're going to draw a line, and I just do dotted lines here, through that point. Okay, that's your vertical asymptote. Vertical means it should be a line that goes up and down. So the horizontal asymptote is at y equals -2. So your y-axis is the one that goes up and down. You're going to go down 2, and you're going to draw another dotted line through that point. So those two lines that I drew there in red, those are talking about like my boundaries of my graph. My lines from my graph here, my hyperbola, cannot cross those red lines because it causes the function to become undefined at that point. If I put in a -3, I'm going to get a 0 in the denominator, and your calculator will literally not do it for you. It'll say, no, it's an error, it's undefined. Okay, so you can't do anything at those points. So when I go to my graph here for -5, so I'm going to go to the left 5, and then I'm going to go down -2.5. So down 2 and then halfway, I'm going to draw my first point there. Then I'm going to do -4, -3. So I'm going to go to the left 4, down 3. Now you can add more points if you would like. Like you could do -6 and -7 and -8. And you could do other numbers that are smaller than -4 but not -3, but then you're kind of getting into decimals there. Even though you only have 2 points, it's not a straight line. Okay? It's going to be a curved line, but you can't cross those red dotted lines. So it's going to look like this. It's going to eventually get as close as it physically can to that red line, but it's never going to cross it. So now if I go to the other side of the graph, so on the other side of -3, so -2, -1 is another point I have in my XY chart here. I'm going to go to the left 2 and down 1. And the -1 is at -1.5. So left 1, down 1.5. I have 2 points again. And think about that picture that I drew you guys up here. Okay, they're going to be kind of inverses of each other. So this one is going to do a very similar thing, that it's never going to actually cross those red lines. And it's just going to slightly curve right there where those 2 points that you have graphed are. Now there's a bunch of other points out there. I just don't have them on my chart because I'd have to go and plug them in manually to get them. Okay, do we have any questions so far on like how I found the vertical asymptote, the horizontal, the points in my chart? Okay, if you guys turn the page over. I want you guys right now just to start by figuring out what your vertical asymptote and your horizontal asymptote is. Okay, for that vertical asymptote, that's when you set the denominator equal to 0. So we set x minus 1 equal to 0. I add 1, so I get my vertical asymptote to be at x equals 1. What's the horizontal asymptote? What number did they add or subtract to the end of my fraction? 0. There's nothing there, right? It doesn't say plus 2 or minus 3. There's nothing written there. So my horizontal asymptote is actually 0. Y equals 0. If there's no number, it's just going to be on the axis. So that one's just going to be on the y-axis there. Okay, so then the next thing we needed to do is make a chart. From that first problem, what did I say you base your numbers off of? Your asymptotes. And we do it basically off of the vertical asymptote, which we said x equals 1. So if it helps you, like I said, I've seen some students do, they'll put a 1 in the middle of the chart, but they won't actually evaluate it there because you won't be able to, because that's where it becomes undefined. So I want to pick a couple of numbers above and below 1. So below 1 would be like 0 and negative 1. What would be two numbers above 1 then? Good, 2 and 3. Okay, I want you guys to try to fill out that chart and watch that negative sign that's sitting in front of your fraction there, okay? And then once you have it charted in your XY chart here, if you want to go ahead and try to graph it, do that too. Okay, to fill this out here, at negative 1, I got 2.5. When it's at 0, I get 5. Positive 2, I got negative 5. And positive 3, I got negative 2.5. So we're going to go ahead and graph it now if you haven't done that yet. I'm going to start by drawing in my asymptotes first. So x equals 1. Go to positive 1 on the x-axis. Draw a vertical line through that point. Okay, now y equals 0, I said that's actually going to be on the axis. Okay, so already on that black line that I had drawn there. So again, those are like your boundaries that your graph, your lines, your hyperbola, your branches cannot cross. Okay, they can't ever cross those red lines. So for negative 1, 2.5, we go left 1, up 2.5. And then for 0, 5, you don't go left or right any, you just go up 5. So this looks a little bit different than the last one with where our points are at. Because on that last graph, we were like basically in quadrants 1 and quadrants 3. This graph is going to be in quadrant 2. So I'm going to go ahead and just kind of draw that branch in. So the other one then is going to just be reflected over, so it's going to be down here in quadrant 4. So we're going to go for 2, negative 5, to the right 2, down 5. And then right 3, down 2.5 for that last point. And then you should be able to draw your other branch in there.